All right, Bulldogs, plenty of lab work coming up here now. I wanted to show you the diagram of the network we're going to build in its entirety. Now, we're starting with the network over the frame relay cloud. As I showed you at the end of the last video, that's our 172.12.123.0/24 network. And we've also got a loopback on each of the three routers. We're going to check those and make sure they are there, but we're going to add them to the EIGRP config. And we're going to use a host mask for those, a host wildcard mask. And we've also got an Ethernet segment, 172.23.23.0/27, that we're going to add as well. But first, let's get our main adjacencies up between routers 1, 2, and 3. And we will start down here at router 3. And since we did some lab work, I just wanted to run show IP protocols. It's a good idea to run that one when you've been running a lot of labs, and just make sure you got rid of all your old protocols before you start a new one. So it's a good lab tip for you. Now let's see, we've got router EIGRP 100, no auto, and then network 172.12.123.0. A couple of very important points here already in our EIGRP config. We know the number is the autonomous system number. That's our logical grouping for EIGRP, and that has to match between potential neighbors. This no auto command, I have a full lab for you that you're really going to get a lot out of later in this section about auto summarization. EIGRP has auto summarization running by default. And as you'll see in the route summarization section of the course, I love route summarization when you and I, the network admins, determine when and where it is done. That's the way it needs to be, and not just because we're on some kind of power trip, but because sometimes EIGRP's auto summarization can actually screw up our routing. And I've got a lab ready for you that we're going to run later, and it will show you exactly what I'm talking about. But I didn't just want to enter no auto here and not tell you what that was. Now again, auto summarization's on by default. And you see the command no auto so often that people think that's the default setting, that it's in every EIGRP config, and it's not. It's so automatic, no pun intended, to type no auto that sometimes I do it when I've already set it once. Just do router EIGRP 100 but no auto. So if I do that here, it doesn't mean you have to keep re-entering it. You only need it once on a router. Also note that the wildcard bits in EIGRP are optional. They're not optional with OSPF. We know that. But with EIGRP, it's actually optional. I strongly recommend that you use them. Cisco recommends that you use them because if I just put in network 172.12.123.0, it actually goes back to its classful bit, the ABC networks. So it would enable EIGRP on every network every interface on this router that just began with 172.12. because that's a Class B network. So we don't want to do that. We want it enabled only on interfaces that begin with 172.12.123, and then about the fourth octet, we don't care. So what would my wildcard mask be for 172.12.123.0? That's an easier one. It's right on the octet border. It would be 000.255. Because our wildcard masks, of course, they're inverse subnet masks. The zeros are the I care bits and the ones are the I don't care bits. So with this network statement, what we're saying is we're enabling EIGRP on every interface on this router that has the first three octets exactly 172.12.123, and then after that, for the fourth octet, I don't care. And that's it. So let's go to routers 2 and 1, and we're going to put the exact same config on. Again, that's optional. It's one of those optional, it's kind of like those optional NFL camps they have before the season. They're not really optional. That's kind of the way this is. So let's get router EIGRP 100, no auto. And that's it. No fancy schmancy config needed on the hub for hub and spoke. We don't have all the OSPF concerns with the neighbor command and then changing priorities on the spokes. We don't have to do any of that with EIGRP. Now, the adjacencies won't come up immediately, but they should come up pretty shortly. And there's one already, and I know I've got the font larger, so occasionally a longer message is going to go off the screen. I'll show you the rest of that. But notice dual at the very beginning of that. That's our EIGRP protocol, or our algorithm, I should say. And EIGRP 100, it's a neighbor change, even tells you what it is. 172.12.123 is up, new adjacency, and we just got that same message about .2 as I was doing that. So everything there is great. And let's take our first look at the neighbor table. And, self-explanatory stuff here for the first half. Now, the second half of it, after SRTT, which stands for smooth round trip time, by the way, don't worry about anything from this side over right now. That's not what we're concerned about. What we're concerned about is this information. This is the most important to us. And we've got our address of the neighbors, the interface through which the adjacency is formed, the hold time, which we know in EIGRP speak is the dead time, and that should keep kicking up on occasion. And you can see the bottom one's already incremented right back up to 169. And we've got our uptime, and that's fantastic too for when you're troubleshooting EIGRP, checking flapping routes, looking for lost adjacencies, anything like that. When you have your neighbor relationships, it's going to tell you right there exactly how long you've had it, which is a pretty good deal. Now let's look around a little bit. I ran show IP route EIGRP and didn't get shown anything. Why don't I have any EIGRP routes right now? Why isn't 172.12.123.0/24 appearing as an IP route when I enable the interface with EIGRP? Because it's a connected route. Remember, you're only going to see routes that EIGRP discovered when you run show IP route EIGRP. You're not seeing 172.12.123.0 there because EIGRP didn't discover it. It was already connected, so it didn't need discovering. A couple other things I want to share with you here in the routing table, the route code table, before we move on. Why do we have the letter D standing for EIGRP? That's a little odd. We're going to see all kinds of D's here in the routing table pretty shortly. But, we had a pattern down, right? We had C for connected, S for static, R for RIP, O for OSPF. We have different kinds of OSPF routes, but still, there's going to be an O in front of all of them. So why in the world do we have D for EIGRP? Well, it's not to screw with you on the exams, although it may seem that way. The reason we have that is because, remember, EIGRP wasn't the original version of this protocol. IGRP was. And now you're thinking, well, hey, IGRP doesnn't begin with an E either, so why does that matter? Well, by the time that EIGRP, the enhanced version of IGRP, was developed, another protocol already had the letter E, the External Gateway Protocol. You may never use this, and it's definitely not something we go into the CCNA, but the scientific method is I was here first. EGP was here first. It took the E, and that was all there was to it. So what Cisco did when they developed EIGRP is they just went one letter backwards, and just like HAL and IBM, they just went backwards from EIGRP to the letter D, and that's why you see the letter D there. Now, let's talk very briefly about this external route, because I want you to know this. What's an external route with EIGRP? Well, as we add these routes throughout our labs here in the EIGRP section, you're going to see the letter D, but you'll never see the letter EX next to any of them, because an external route is a route that is learned via route redistribution. It's one of my favorite things to do. I love it, and boy, it can blow your network up if it's done the wrong way. So it's something we save for future studies. But the deal is, let's say we had OSPF and EIGRP running on the same interface, because you need to know this. You need to know what route redistribution is. If you had OSPF running on this router and EIGRP running on it, they're not going to know about each other's routes by default. They are two totally separate processes. But let's say that you had one OSPF route, or maybe multiples, that you wanted your EIGRP speakers to know about, that you wanted advertised to your neighbors. What you can do is perform route redistribution. We would take those OSPF routes and do what we call injecting them into the EIGRP autonomous system. When that happens, they are going to be advertised as DEX. EIGRP external routes because they're learned by route redistribution. They have a higher administrative distance than your regular EIGRP routes. We're going to see the EIGRP routes with an AD of 90. Remember, the administrative distance of measurement of a route source's believability. EIGRP routes have an AD of 90. EIGRP external routes have an AD of 170. It's good stuff to know. Just a little bonus material there about route redistribution, EIGRP, and how we got that routing table code in the first place. Now, everything's just fine and dandy right now. We've got our adjacencies up, but we need some routes. So when we come back to the next video, we're going to introduce the loopbacks into EIGRP. We're going to remind ourselves what a host mask is, and also we'll bring in that Ethernet segment, and then we'll start really diving into the topology table, and we're going to review our feasible successors and our successors, and then we're going to get into load balancing from there. So a lot of great lab stuff coming up. I'll see you on the next video.